Okay, so let's go to the agenda. It was just pointed out here that the agenda says that assignment one is due the week of this week. Okay, that is today is 9/18, and so A1 due means what? Does it mean it's due today? No, it doesn't mean it's due today. Okay, what does it say here? Okay. All assignments, okay, A1 through A4 are due Saturday midnight of the week listed, okay? So assignments are never due on Tuesday, okay? But it does say that A1 is due this week, which would mean it would be due this coming Saturday, okay, at midnight. But that's incorrect. It's going to be due next week, okay? That's because it takes a little longer to do this assignment because of the way we did it. You got to select these companies, and so it takes a little bit longer. So it is not due this coming Saturday, but it will be due Saturday, 9/29. Okay. So we are in the fourth week of class. I'm already supposed to be talking about software. Actually, I'm back over here. I'm back over here. I'm this far behind. I never even talked about hardware yet. Okay. Or intellectual property rights, or OS web research. So I'm going to talk about intellectual property rights right now. And I'm not going to talk about it too terribly long because it doesn't take that long to cover. But it is an interesting issue. This is the first time I've been talking about an issue. I mentioned at the very beginning of this class that this class covers concepts, issues, and skills. Okay, the concepts are computer concepts. Okay, like hardware, software, so forth. The issues are social issues that have been brought up because of computing. Okay, or has been changed in some way because of computers. One of these issues is intellectual property rights. So, what is what is intellectual property rights? Anybody have any idea what that means? Yeah, yeah. So, is an idea worth something? Is it worth some worth? Is an idea worth some money? How do you protect an idea? Yeah, she's good. She's like, are you a lawyer or something? You know this stuff, huh? So, your name is Tiara. No, you are Allison. Man. Yeah, yeah, Allison. Okay. So Allison said the following. Okay, if you want to protect intellectual property, she said you can copyright it, copyright your idea, or you said trade secret. Did you say trade secret? Trademark. And then there's also suggested that you can patent it. So, whether you copyright it or trademark it, okay, or copyright it, or there's also another thing called trade secret. I mean, a trademark is something like a logo or something, okay? Something simple, you know, a picture that represents the logo of your company, say, can be trademarked. But something like, say, a piece of software that's important to your company, you can't trademark the software, but you can treat it as a trade secret. Now, to treat something as a trade secret means you don't do certain things, right? You don't talk about it too much, and you don't go into the internal details of it, and you basically don't tell people certain things about it. Okay, I mean, let's say it's the recipe for Coca-Cola, right? You don't let people know what the recipe is, right? And so that means that when you make some of it, you know, you put you got a chemist in your uh, shop there that's doing this, okay, but they have to be, you know, sworn to secrecy. They don't tell anybody, you know, and not too many of them actually know what's going on. Well, does anyone know if you do get a copyright on something, okay, and software, computer software is mainly guarded by copyright rather than patent. However, there have been cases where computer software has been patented. Does anyone know how long a copyright lasts? No, more. How long does a copyright last? Copyright lasts 99 years. And it's the longest of all. How long does a patent last? No, patents only last 15 years. And how about trade secrets? How long do they last? Well, they last as long as you can keep them a secret, okay? And if you wanted to sue somebody for infringing your copyright or your patent, would you sue them in state court or federal court? What? No, these are done in federal court. Trade secrets are done in state court. Uh, I've been involved in a number of law cases. They hire professors as what are called expert witnesses, and I've been on civil cases and I've been on criminal cases. Um, Most of the cases that I have been involved with are trade secret, okay, done in state court. And most of the cases I've been involved with are concerned with software piracy. Now, what is software piracy? Well, when somebody, steals your software. And most of the cases I've been involved with are like the following. Here's a company, and it has some software that's vital to the company. This software actually is what runs the company. And then some of the people in the company, normally the ones who are in charge of the software, leave the company, often sort of en masse, okay? Or maybe just two or three of the main people who know the software leave the company. And then they form their own company, and then in a very, very short amount of time, they already have a competitive product. And the management of the company they left feels like they have cribbed. They have taken our software with them. Okay? They may have massaged it, they may have changed it, but basically they could not have built, this very complex software system in such a short time. And besides that, it looks an awful lot like our system, okay? And they're going after our customers. And they've already lured some of our customers over to their company. And so the old company sues this new company uh, for trade secret violation. And it's kind of a very interesting thing. Uh, so they hire me, and then the judge it's what's called a discovery ruling, and both companies have to give me their software. They had to give me copies of everything. Their running software, they have to give me copies of their source code and all versions of it. And I go through this stuff, and it takes a little bit of time to do it, to see if uh, I feel like it's been stolen or not. And so it's just a very interesting thing. So, intellectual property rights, okay, concern the legal ownership and use of intellectual property such as software, music, movies, data, and information. Okay? So, piracy, I just talked about plagiarism. Okay, I will talk about it. Let me ask you this, okay? Suppose you work for a company, and let's suppose you invent something when you're working for this company, and you get a patent. You know, who owns the patent, you or the company? Well, normally, when you go to work for a company, you have to sign some things, right? And usually, the things that you have to sign and put a little document of it, it says that anything is invented, intellectual property, that comes out of your association with the company belongs to the company. So at one time, I worked with a guy named Jack Kilby. You'll hear more about Jack Kilby a little later in this course. He won the Nobel Prize. What did Jack Kilby win the Nobel Prize for? Anybody know? He won the Nobel Prize for integrated circuit. And he won this. He invented this integrated circuit when he worked for Texas Instruments. It's in Dallas, Texas. So in fact, Jack Kilby was in charge of this group that invented the integrated circuit. So one time I said to him, I said, Jack, how much money did you get for inventing the integrated circuit? He said, I got $1. I said, well, that doesn't sound like a very good payoff for such an important invention. And he says, well, I work for TI and I signed this, it all belonged to TI. He says, but when you got, a patent and you were responsible for it, TI had a little ceremony. They gave you $1. It's a little frame, and it says what all about. He says, you take this little frame, this dollar, you normally just put it on the wall in your office. He said, it's still on my wall at home now. And I said, well, how much money did TI get from this? He says, well, and he says, back in those days, people didn't take intellectual property as seriously as they do now. He said, I don't think they ever made more than 500 or 600 million. So you can see that intellectual property, can be an important thing. Now let me ask you this about a university, okay? So you're students at a university. So let's suppose, you're not graduate students yet, right? But let's suppose you hang around with some graduate students and get involved in some research project, okay? So here's this professor, or maybe more than one professor, okay? It depends on the project, right? And then there's some students, of which you're one of the students, okay? And you're working together in this lab, and let's say you invented something, like an integrated circuit, or something. Right? Now, suppose that gets patented by the university. Who owns that patent? Well, universities are more open than companies normally. Most universities will have an intellectual policy, intellectual property policy. Okay? And University of Houston has an intellectual property policy. Here's what the University of Houston's intellectual property policy is. It says if money comes in to the university, from this patent, or if you say license this device or whatever it is, on the first $100,000 per year, the university splits it 50-50. The university gets 50%, and the group of people who did this gets 50%. Now, how much does the professor get? And how much do the students get? Let's say there's one professor and three students. Okay? All together, the four of them get 50%. Okay? How much does the professor get? How much do the students get? Well, you better have an agreement on that. Okay, I mean you should. The professor and the students. It would be good if they had talked about this ahead of time. Okay, and had an agreement where everybody was going to get an equal amount. Or whether the professor was going to get more than the students or what. Okay? Or if sometimes the professors don't want anything, just let the students have all of it. You'd be surprised. We've had that happen. And but then on the next 100,000, so the second $100,000, the university takes 60%, and these people get a party. And on the next 100,000 after that, it's 70-30. And it's 70-30 for the rest. Okay, but after 1 year, it starts all over again. Next year, again, the first 100,000 is 50-50 and so forth. So that's the policy at the University of Houston. You trying a new policy? Yeah. Well, I guess I should say, I'm not even certain what I told you is all that. That's the last time I looked at it. I haven't actually looked at it in some time. So, what's he going to change it to? Okay, I see. Okay, what's plagiarism? Um, Piracy and there's plagiarism. Okay, so piracy involves illegal copying, use, and distribution of intellectual property. This is like the people who leave the company. Actually, in the computer business, the way it's normally figured is this: if you leave the company, you're working in this company and doing software development. Now you leave the company, then the correct way to leave the company is to just leave it. Anything that's in your head is yours. But anything that's on disk, on tape, on paper, or anything else like that, okay, notes, written notes and so forth, you leave that, okay? But you take your head with you. And then whatever you can reproduce, in your new company from what you have in your head, that's legal. Plagiarism involves taking credit for someone else's intellectual property, typically a written idea. Copy and paste. So this is like, it's like, say, you as a student have to write a 4-page paper on this company, right? What's the easiest way to write a 4-page paper? Well, you go to the internet, right? You find some article about this company, and you cut and paste, right? Have your Word document over here doesn't have anything. You have the internet over here, so you just copy, paste, copy, paste. There's your 4 pages right there. Yeah. That's all plagiarism. Okay? And what are you supposed to do? Does that mean you can't copy and paste? Is that against the law? Well, it is against the law. Now, we're certainly writing a little paper for this class, right? So, you're not going to get in a whole lot of trouble. However, if the readers find that that's what you did, you're not going to get a very good grade. Does that mean you can't copy and paste at all? No, you can do that. If you're, so you're writing this paper, and here's your Word document. Now, let's say you're writing this Word document, these are your own words, okay, and you're thinking about this company, and you know what to say, man. We have these margins, right? And so, this is just, you're writing your stuff here. Now you get to something that you'd like to copy from the internet. Well, it depends on how much you want to copy. If it's something short you want to copy, what you do is you put in quotes, okay? Quote, okay? And you say what it is, quote again, afterwards, okay? And then afterwards you put a reference in, say, square brackets, and here there'll be some type of reference. Now, the proper type of reference, you look at that article that I gave you, okay, from the Modern Language Associates, okay? And that tells you exactly what you should put, how the reference should look in the document, okay? Now, if you put that information in without those quotes and that reference, you're taking credit for it yourself. That's plagiarism. And if you're caught doing that, that's,
you can, be sent to jail for it. I mean, but that's not going to happen for this class. On the other hand, if you want to copy something more substantial, than just one line or two lines that would be in a quote, then you're supposed to indent. And then when you get to the end of what you put in, then you go back. And in this indentation, okay, you also say, you don't only say in so many words, okay, the following, is a quotation from so and so, right? And then all that's indented, okay? And so that's all explained in the information, that I gave you here. But it's very important to do that. Now, in your 4-page report on your company, it's good if the whole thing is not indented, right? You want these indentions and these quotes to, it's good if they're there because it shows you did research. See, this is supposed to be a research paper. And a research paper is, has references. Let people know you read all this stuff and you are on top of all this stuff and you know what other people have said about it. Okay? And so you want to have these references. Uh, you can have the reference without having a quote. Okay? You can say this company has been reviewed by, this company has been reviewed by this, and this. Okay? These are references. Okay? Or you can say the financial history of the company, is found in X, X, and X. So don't write your paper by just cutting and pasting. Someone says if you steal from one person, that's paper. If you steal from 20 people, that's research. Okay, digital rights management, DRM, okay, is a technology that protects digital forms of intellectual property. What's a form? Digital form of intellectual property? Well, it's let's say if it's software, you've got the code, the software code, is a file somewhere, and that's a digital form of intellectual property. So it restricts the number of devices and applications on which the file can be opened. Then there was the Digital Millennium Copyright Act, DMCA, okay. Right around the millennium, okay, the U.S. Uh, had a copyright law designed to reduce illegal digital media copy by criminalizing the production, distribution, and use of technology. Uh, so there's one country in particular that gives us a lot of fits here, okay, about copying stuff and not paying their royalties. Okay? What country is that? Copies all of our movies, songs, other things. It doesn't pay anybody anything. I know. There's a big problem with China over that. Okay? And that's something that really needs to be straightened out. I hope it will be straightened out. It, um, I mean, it used to be each country had its own copyright laws. Then they got into these international agreements. Yes. Yeah, yeah, yeah. so they have digital watermarks now, by the way. And so if you have a document and it's something that is important from an intellectual property point of view, you can put this digital watermark on it. And then if that appears there, that's direct proof, of copying. Okay, so that's about all I have to say about intellectual property. And so we've now covered that. So there might be then a question or two on the first quiz, okay, about intellectual property. Okay, I'm going to go back to digital technology again. Uh, what do I expect you to know in the field of digital technology that might be on a quiz? Okay, well, I expect you to know about number systems. I particularly expect you to know the binary number system, the octal number system, and the hexadecimal number systems, and of course the decimal. I expect you to know the theory of a positional number system. What do I mean by know the theory? Well, what that means is you know that a 961, okay, decimal uh, means 9 times 10 squared plus 6 10 to the first power plus 1 times 10 to the 0th power. Oh, and 1011, okay. In binary means 1 times 2 to the third power plus 0 times 2 to the second power plus 1 times 2 to the first power plus 1 times 2 to the 0th power. That is, when we write 961 in decimal, it's just shorthand for all this. We don't want to have to write all this out because it's too long, and cumbersome. We just use the shorthand here, but we know that's what we're doing. Okay? On the theoretical side, you should know that binary only has, well, let me call them ciphers. 0 and 1. They're really digits, okay? Bits, okay? That's 2 bits. There's only 2 characters, okay, in the binary number system, 0 and 1, okay? And decimal has 10, okay, characters. 0 through 9. Okay? And octal has 8, and hexadecimal has 16. Okay? I might ask you quiz about, I mean, those 4 number systems are really the only ones that are important in computing. Why is octal and hexadecimal important in computing? Well, they're important because of their relationship to binary. One octal character. Binary bits. One hexadecimal character is equal to 4 binary bits. So I expect you to be able to convert from binary to octal, binary to hexadecimal, hexadecimal to binary, binary to hexadecimal, hexadecimal to octal, okay? Because those are easy. Binary, here's octal, here's hexadecimal. And we call hexadecimal hex usually, just hex. So a binary 1 in octal is written 1. A binary 1 in hexadecimal is written 1. A binary 2, 2 in binary is written 1, 0. In octal, that's 2. The hexadecimal, that's 2. 3, 4, 5, 6, 7, 8, 9, So notice octal goes 1, 2, 3, 4, 5, 6, 7, 1, 0. Why is that? Why does it go 1, 2, 3, 4, 5, 6, 7 and suddenly this is 8, right? 1 times 8. Okay. This is the 8th position here, not the 10th position. This is the 8th position. 8 plus 0 is 8. 8 plus 1 is 9. In binary, this is the 1, 2, 3. I'm sorry, the 1, 2, 4, 8th position is over here. 8. No 4, no 2, 1. 8 plus 1 is 9. Ten in binary. 8 plus 2. Okay. This is 1, 2, 4, 8. Okay. 8 plus 2 is 10. In octal, okay. 8 plus 2. Okay. In hexadecimal, we write 8. 11. In octal is this. In hexadecimal, it's a B. 12, okay, is a C. 13 is 8 plus 5 is 13. 14 is 8 plus 6. 15, 16, so this is 1, 2, 4, 8, 16. Here this is 2 times 8 is 16. Here 1 times 16 is 16. 17. So it's easy then to convert hexadecimal and octal into binary. Actually, octal is a little bit obsolete, okay, because it used to be that a byte was 6 bits, okay, or 2 octal digits. Yeah. So suppose we want to convert 4, 6 in hexadecimal, okay. We want to convert that into binary. How do we do it? We just take the 4 and write it as 4 binary bits. 0, 1, 0, 0. And then we take the 6 and write it as 4 binary bits. 1, 1. I'm sorry. The 4 is 0, 1, 0, 0. The 6 is 0, 1, 1. That's 4. That's 6. You can do it, digit by digit. Now let me ask you this. Suppose you want to take 46 decimal and convert it to binary. convert 46 octal to binary. You just do it digit by digit. Each octal character is 4 binary bits. But decimal, how would you do it? How do you convert decimal into binary? Well, the way I've always done it is I just put some dashes out like this. And I say this is the ones position, the twos position, the fours position, the eights position, the 16's position, the 32's position, the 64's position, and the 128's position. Now, how do I do 46 in binary? Well, I go out here to the biggest one that's less than 46. Okay? 1 is smaller than 46, 2, 4, 8. 32 is smaller than 46, but 64 is bigger than 46. So I know I can't use any of these that are bigger. So I put in a 32, and then I just subtract that 32 from the 46 to see what else is left over. Okay. Then I say, how do I represent 14? What's the biggest thing? The 16 is too big, so I put a 1 there, and then I subtract 8. And then 4. I subtract that, and I have a 2. And that's the way I do it. In your textbook, when it talks about converting decimal into binary, they do it like this. If they want to convert 46 into binary, what they do is they divide the 46 by 2, okay? And they will say that's 23 with a remainder of 0. And they'll take the 23 and divide it by 2. And then let's say 11 with a remainder of 1. And they'll take the 11 and they'll divide it by 2. And they'll say that's 5 with a remainder of 1. And they'll take the 5 and they'll divide it by 2. And they'll say that's 2 with a remainder of 1. And they'll take 2 and divide it by 2. That's 1 with a remainder of 0. Okay? Then they take the 1, and then they'll take the 1 and divide it by 2. And they'll go 0 with a remainder of 1. They'll do this until they get a 0 down. They start with 46 and then 23 left. They keep going until they get a 0 down here. And then all this stuff over here is the binary representation, okay? From bottom to top, okay? Starting down here, 1, 0, 1, 1, 1, 0. So this is the ones position, this is the twos position, fours position, eights position, 16's position, 32 position. So in the clears, there'll be some conversions, okay, between binary and decimal and binary. So you should look at that.
Now, I'd also expect on a quiz you to know about data types, okay? What? It's next week. Yes. Quizzes are always on Thursdays. So what would I expect you to know about data types? Well, I'd expect you to know a few data types, okay? Particularly, I'd expect you to know what? Integer data type, right? What would I expect you to know about the integer data type? I would expect you to know how much memory each integer takes. How much is that? How much memory does an integer take? 4 bytes. You can either give the answer in bytes or in bits, okay? Yes. 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 And also I made it true false. So another thing about the integer data type is what integers can it represent? Or I guess I ought to say more, better to say, what's the largest integer, okay? Or what is the range, okay, of integers can be represented? I mean, you ought to know it's basically plus or minus 2 billion, right? Of course, you can always say, oh, about 32 bits. But I mean, when I say that, I want to know the range the way humans normally think about number ranges. Okay? Integers are plus or minus 2 billion. I don't require that you actually know the exact number. Okay? Although I would expect you could figure it out if you wanted to. But just that it's plus or minus 2 billion. Okay? That's all I really want you to know about integer types. Okay? But you know they're 4 bytes long and they represent this range here. Next data type is character. What I want you to know about a character data type. Same stuff. How much memory does it take?
again, you're going to answer in bits or bytes, right? What's the answer? 1 byte, yeah, or 8 bits. Both those answers are right. 1 byte is correct. 8 bits is correct. And what's the range? Okay. Well, the range is basically the characters on the keyboard. You know, there'll be 256 altogether, right? Possible. 256 possible. I guess I want you to know um, what is the mechanism for storing integers? Okay. The answer is the binary number system. And what is the mechanism for storing characters? ASCII code or the Unicode? ASCII kind of the old way, limited really to our alphabet, one alphabet. Unicode, the new universal way of storing characters. And I want you to know what is the mechanism for storing pixels? And nowadays, all computers, use RGB. Okay? That is, there's a red byte, a green byte, and a blue byte. Okay, so 24 bits there, or 32, because often there's a control byte over here. It's usually written this way: Control RGB. This control byte is sometimes used, but sometimes not. I mean, it does have stuff in it often, particularly what's called the alpha bit, alpha, alpha bit, alpha. That's translucence. Okay? If the alpha is 0, the color is a solid color. If the alpha is a 1, it's a solid color. If the alpha is 0, it's completely transparent. You can see it. If the alpha is a half, you can kind of see through it. Okay? It's the measure of how much you can see through this color. Because in computers we want things that you can see through sometimes, okay, like a colored window or something. And then I want you to know about digital convergence. What is digital convergence? Digital convergence is the understanding or the knowledge or the realization, I guess, that everything that we want to put on paper, okay, or store in a computer can be stored with zeros and ones because we have all these mechanisms for doing it. We don't use the same mechanism for every data type. We have different mechanisms for different data types, but we have a mechanism. Okay? So we can store pictures, we can store characters, we can store integers, we can store songs. Everything can be stored with zeros and ones. Okay? And therefore, the computer in one, I guess, device can basically handle everything of an intellectual type. Notice if you take, say, the number 7, the number 7 can be stored as a character, right? It's on the keyboard, right? How is a 7 stored as a character? It uses the ASCII code. Okay? Stored as a 3, 7. Okay? In hexadecimal. It's stored as 0011. That's a 3. 0111 is a 7. So if you were to type in the number 2,764, you would type 4 characters on the keyboard. You'd type 2764. That would go in the computer as 4 bytes. Each, there'd be 4 characters, okay? And you cannot compute with those, okay? Because they're not integers. You can compute with integers, you cannot compute with characters. So you have to take those 4 characters and convert them into a binary integer before you can do any arithmetic with it. So you read it in, you convert from the ASCII code to binary. You do all your arithmetic in binary. And when you get an answer, you have to convert that answer back to characters in order to print it out. Okay, well, I guess that finally is the last thing I'm going to say about digital technology, okay? So next time I'll start talking about hardware. Okay? Thank you very much.